Going on, guys? Let's look at this problem right here. This question is asking a relativistic proton has a momentum of 1.0 times 10 to the power minus 17 kilogram meter per second and a rest energy of 0.15 nanojoule. What is the kinetic energy of this proton? Here the question is asking us to find out the kinetic energy. Now let's look at the given information. Here we have the momentum provided, that's equivalent to 1.0 times 10 to the power minus 17 kilogram meter per second, and also we have the rest energy provided, that is E naught, that's equivalent to 0.15 nanojoule. Okay, now we are trying to find the kinetic energy, and in relativity the kinetic energy related equation is this one. This is one of them. E is equivalent to kinetic energy plus m naught c square. Now let's see whether we have all the information available. Now if you look at this energy, this is not here because this is E naught, rest energy is provided, but we don't have the relativistic energy, so we have to do something about that. Here we are trying to find kinetic energy. This is our question, and m naught c square, E naught is equal to m naught c square, so you don't have to worry about that one because you can replace this one m naught c square with this one 0.15. okay, now for E what we can do is we can bring another equation that is related to E, that is given by E is equal to square root of p square c square plus m naught square c power 4. Here we have the momentum provided, that is 1.0 times 10 to the power minus 17, and also we have the speed of light, and m naught square c power 4, if you look carefully, this is the square of this one. E naught is equal to m naught c square. If you square this one, this is going to give you m naught square c power 4. Okay, so we have everything available. So what we can do is, instead of writing E, we can equate this ke plus m naught c square to this one. In that way we have everything known. Okay, now let's go ahead and do that. This is going to become p square c square plus m naught square c power 4, that's equivalent to ke plus m naught c square. Now let's go ahead and plug the values. Here we have the momentum square. In our case, momentum is 10 to the power of 1 times 10 to the power minus 17. We can just write 10 to the power minus 17 because 1 time doesn't make any difference, right? So this is going to be just 10 to the power minus 17 square, and then c square is going to be speed of light square, that's going to be 3 times 10 to the power of 8 square. We can directly square that one, that's going to be 9 times 10 to the power of 16. And in the other side we are going to have m naught square c power 4, that's going to be the square of this one, 0.15 square, and then 10 to the power of minus 9 square, that's going to be just 10 to the power of 18 or minus 18. And that's it for this side. Now let's look at the other side. Okay, 10 to the power of minus 18, and that's it, right? In the other side we have kinetic energy and m naught c square. Instead of m naught c square, we can directly put this 0.15. So this is going to be 0.15 times 10 to the power of minus 9. Now let's bring this part here. Okay, let's try to simplify this one. Here we have 10 to the power of minus 17 square, that's going to be 10 to the power of minus 34. 10 to the power of minus 34 plus 16, that's going to give you 10 to the power of minus 18. So we can put 9 times 10 to the power of minus 18. Okay, and in the other side we have 0.15 square, that's going to be equivalent to 0.0025, 0.0225. So this is going to be 0.0225 times 10 to the power of minus 18. Okay, in the other side we are going to have kinetic energy plus 0.15 times 10 to the power of minus 9. Okay, now let's try to simplify this one. Here we have the same power, so we can add them together. This is going to become 9.0225, and this 10 to the power of minus 18 is going to be multiplied, but we can take this one out. If we take this one out of the square root, that's going to be 10 to the power of minus 9. And in the other side we have kinetic energy plus 0.15 times 10 to the power of minus 9, and if we square root this 9.0025, that's going to give us 3.0037 times 10 to the power minus 9. And in the other side we have kinetic energy is plus 0.15 times 10 to the power minus 9. Here you can see we have the same power, right? We have same power for 3.0037 times 10 to the power minus 9, and here we have 0.15 times 10 to the power minus 9. So when we have the same power, we can directly subtract this one. So this is kinetic energy is going to be equivalent to this one, 3.0037 times 10 to the power minus 9 minus 0.15 times 10 to the power minus 9, and if you subtract these two together, that's going to give you 2.8537 times 10 to the power minus 9. 10 to the power of minus 9, this is in joules, and 10 to the power of minus 9 is nano, so we can write 10 to the power nanojoule. And also the question is asking to give us in 2 decimal places. In 2 decimal places we are going to have 2.85 nanojoule, and that's going to be our final answer. I hope this helps. Thanks for watching.